Good evening, everyone. I am Saranya, Assistant Professor in Computer Science and Technology from SNS College of Engineering. Now, I am topic is a dynamic programming. A dynamic programming is a problem solving to define a formulated at formulated as a recurrence process. The dynamic programming is requires to problem divided into overlapping a subproblems. Subproblems can be represented by a table. The third thing is a principles of optimality recursive relations between a smaller and larger problem. It is compared to a brute force and recursive algorithm that could run exponential. The dynamic programming algorithm runs typically in a quadratic time. The recursive algorithm ran in exponential time while the iterative algorithm ran in the linear time. Yeah, for the examples of the dynamic programming algorithms are the computing a binomial coefficient, longest common subsequence, Warshall algorithms for the transitive closure, Floyd's algorithm for the all pairs shortest path, constructing a optimal binary search tree. Some instance of the difficult discrete optimization problems in the travel salesman problem and snapshot problem. A first thing is a computing a binomial coefficient. A binomial coefficient is a non-optimization problem but can be solved using the dynamic programming. A binomial coefficient are represented by C of n comma k equal to n factorial divided by k factorial of n minus k factorial or into n by k, and can be used to represent the coefficient of a binomial a plus b whole power n equal to C of n comma 0 into a power n and b of 0 plus up to plus C of n comma k into a power n minus k and b power k plus up to plus C of n comma n into a power 0 and b power n. The recursive relation is defined by the previous power. The C of n comma k equal to C of n minus 1 comma k minus 1 plus C of n minus 1 comma k into for n greater than k greater than 0 with the initial conditions of C of n comma 0 equal to C of n comma n equal to 1. A dynamic algorithm constructs a nxk table with the first column and diagonal filled out using the initial conditions. An algorithm for the binomial of n comma k for I tends to 0 to n do to fill out the table row wise for I equal to 0 to minimum I comma k do if j equal to 0 or j equal to I, then C of I comma j tends to 1. It is an initial condition. Else C of I comma j tends to C of I minus 1 comma j minus 1 plus C of I minus 1 comma j equal to recursive relation for the return of C n comma k. A cost of the algorithm is filling out the table. The addition is the basic operation. Because of k less than or n, the sum needs to be split into two parts because only the half the table needs to be filled out the filled out for I less than k, and remaining a part of the table is filled out across the entire rows.